few that may remain on the viewing list. This is the third video showing how I make the Nissan DeltaWing or such a type of car in rFactor. And we've had two quite boring videos, perhaps, I don't know. If I think they're boring, then probably you've all dozed off and gone on with your lives and do more interesting things. But I'm sticking with it for a little while. The DeltaWing, creating it in rFactor with my spreadsheet and tools. Today I'd like to make the engine, which is probably a bit more exciting than all the weights and inertia stuff that we had to do. And with engine you need data, and luckily they provide some essential numbers here. That's sometimes you don't get like a torque curve, but you get some of these specs, so I reckon it'll work. Zoom this one out. Alright, engine. We have the torque curve here and the power curve. And let's start with the parameters. Inertia of the engine, well, that depends on its displacement and all the rotating bits that are attached to it, which I do not know yet. It's fairly small engine, so my first rough assumption will be this value. Stall RPM 750 is fine, idle 1500. No idea, but it's probably acceptable. Maximum torque, well, looking at the data they say, well, there's a constant torque from 4000 to 7600 something RPM. Okay, well, I have to enter a point and just be really close to a flat line. So let's take more or less the average. Already 4006. What's the average? Well, we're using Excel. Well, let's calculate it by being lazy. 5375. Maximum power is at 7400 RPM. Have set an upper limit for the revs that the engine will do, so I'll make that 9000. I guess by that time the engine is almost broken. The performance maximum torque 310, and the power they say is 300. Now look at this curve, that's quite nasty. I have to fix that. So here is the torque curve, and based on the RPMs that I've entered here, it sort of picks a few points, and then I can easily adjust the torque percentage. And flat from 4000. Alright, so that's 99.5, and yeah, still 99.5, 99.9. Okay, it's already looking pretty much like a nicely flat curve. And here are some readouts of what it thinks of the engine now. So we still have some smoothing of the curve to do. Drops off a bit too harshly, so that looks a bit better. And then a bit more like that. That's too much. It's not too bad. Yes, now it thinks the peak power is at 7200 something, which is not quite right. That's better. So yeah, that's fairly close. I put it at 8000, probably reasonably okay. There is engine braking here, engine braking torque curve, which is fairly high at the moment, but it's a turbo engine, I don't know, may have more back pressure, don't know. Fuel consumption, this is fairly neat, because it's a random, well, it's not random at all, but it's a number in rFactor that's, well, what is the number? Some tiny number that you really cannot interpret. So where is the fuel consumption? Yes, it's 2.5 E minus 5, so it's 0.000025 something. That's a number that doesn't make obvious sense, and it also isn't constant. If I have an engine that does 20,000 rpm and then one that does 10,000 rpm, then the fuel consumption isn't constant. It will result in different actual fuel consumption because the engine does more rpm and each rpm burns a bit of fuel. So I've simplified this here and I figured out how it works. So I set the rpm that I wish to calculate the fuel consumption for. Well, let's say most of the time average engine rpm is 6,000, and let's say that mostly your average throttle percentage is 70%. Then I simply set the fuel use in liters per minute. They have some fuel consumption numbers here that I have yet to look up, because they have between 230 and 250 GM per kilowatt hour. GM, I think it's grams perhaps. Needs a bit working out to figure out what that is. Kilowatt hour. No idea. Have to figure that out later. For now, I'll say it's fairly fuel efficient and it uses half a liter per minute. There's no engine boost, and we can adjust the engine lifetime here because naturally the engine is quite durable, but not if you do 10,000 rpm. So this value here is the lifetime in seconds, and it's already set at 24 hours. So if you want the engine to last 32 hours, it's 32 times 60 creates minutes times 60 creates hours. No random deviation. And what RPM do you want this lifetime to occur at? Well, somewhere below peak power, I guess 6500. So if you run at a perfect 6500 RPM, the engine will last 32 hours in this case. It's just an example. And then at this optimal oil temp from 110 degrees, that's fine. And then at the second RPM, higher RPM, let's say 9500, the engine should last, well, 1 second if you want it to really get, lose performance, or don't lose performance, but wear out very quickly at high RPM. Or you may want it to last a bit longer, and you already see that this curve changes. This is the lifetime in hours versus RPM, and you can change this curve quite handily, or shift it that way. It's a very neat way to adjust engine wear. And if you would do a 24-hour race, you can tune this so that you may not want to run at the ref limiter all the time, because it sort of puts the engine in near the danger zone. Some other bits and pieces here are just where the flames come out of the car when you do blow it up, and something with heating and cooling that I'm not going to bother with right now. Right, so engine is almost done. I'm assuming now a torque efficiency of 100%, but naturally somewhere in the gearbox and the differential power is lost, so I'm taking 8% off. And that's our engine. I hope you enjoyed it a little bit. I'll be back another time with another aspect of the car, aero or tires or the suspension. Be back later. I hope you enjoyed it, and bye bye for now.